Hi, this is the third video for chemistry and honors chemistry on matter. And we finished our last video talking about chemical and physical changes of matter. And now we're going to look at those changes as exothermic or endothermic reactions. So first we have to have a little review of energy. Energy is not a physical object. It's nothing that we can touch or see. It's a capacity. It's the ability to do something. Now you can do stuff with energy. It can be moved from one place to another. It can be stored. It can be changed from one form of energy to another. You can store it one way and use it in another way. Maybe we need to look at the different forms of energy. First of all, we need to know that energy is conserved. Even though we can change it from one form to another, we will never create nor destroy energy. It's called the conservation of energy law. We're going to change it from one form to another, but we will not create it or destroy it. In chemistry, these are the forms of energy that we're typically concerned with. Potential energy is energy that is stored. There's a lot of potential energy in chemical bonds. Kinetic energy is the energy of motion. Heat is the change in the kinetic energy of particles that results in a change in temperature. Electrical energy is from a charged particle, and electromagnetic energy can be in the form of light or other forms that we just cannot see that are energy in the electromagnetic spectrums, like X-rays or UV rays and so forth. Well, let's talk about an exothermic reaction. Now, the prefix exo reminds me of the word exit, to go out or to leave. Well, an exothermic reaction is one that releases energy, or in other words, energy leaves the system. This release in energy can be in the form of heat. And if an exothermic reaction gives off heat, you will be able to measure an increase in the temperature in the surroundings. But not only heat is a form of energy that can be given off, but light could be given off by the chemical reaction or sound. Endothermic reactions are reactions where energy must be absorbed in order to proceed. If it absorbs heat, the surroundings will feel colder due to the surroundings losing the heat. I want to draw on your background from biology from your freshman year. I'm sure you studied photosynthesis. If you look at this diagram of photosynthesis, we see the leaves of the plant absorbing carbon dioxide and water from the air, and energy is going into the leaf, the energy from the sun. Photosynthesis would be an endothermic reaction. It is absorbing energy. Look how the arrow from the sun is pointing into the system or the plant's leaves. On the other hand, respiration would be an exothermic reaction. This is a pretty complicated diagram, but what really happens in respiration, you get a net gain of 36 ATP molecules, which is a form of energy in the cell. This would be an exothermic reaction because it is producing energy. It's also changing energy from stored energy to chemical energy. Now, we studied the changes in states of matter, And these are physical changes that happen. So remember, anytime we change a state of matter, it's going to be a physical change. If you look on this diagram, here is a solid. Do you see the ice? It's nice and ordered and arranged. And if we add energy to a solid, it will melt into a liquid. And here you got the molecules. They're not nearly as ordered and they're moving around and rolling past one another. And then if you take that liquid state of matter and you add even more energy to it and evaporate it into the gas phase where it has the highest amount of energy. All of these processes, the melting and the evaporation, required adding energy. So those are endothermic reactions. You had to add energy to get it to happen. Well, let's go in the other direction. If we had water vapor and we removed energy and we condensed it down to liquid water, we will be removing energy from the system. And then if we go from liquid water and freeze it down into solid water, which we call ice, again, we're removing energy. We're going to a lower energy state. And all of these processes would be exothermic because they are releasing energy. So let's have a summary. These chemical and physical changes that we've been studying in our last unit, they can be exothermic or endothermic. And exothermic just means that we are releasing energy from the system to the surroundings. And we're in the surroundings. Endothermic is when energy is absorbed from the surroundings into a system. So I want you to know the definitions for exothermic and endothermic. The way I remember exothermic is just like an exit sign, something leaving. So energy is leaving the system, release of energy. And then endothermic, well, it kind of sounds like in. That is when you are putting energy in to a system. Also, when the energy that we're talking about, if it's absorbed and released, if this energy is heat, so it's not light or sound, but if it is heat, you will see a temperature change. So an exothermic reaction where energy is being released into the surroundings from the system, it's going to increase the temperature. And so to us, it's going to feel hot. An endothermic reaction, on the other hand, where it will be absorbing energy from the surroundings, it's going to feel cool because it's taken the heat away from the surroundings. So I hope you have a better understanding of exothermic and endothermic reactions and are ready to do the lab.